Going to tell me on the air. Here we go. I
Pretty
think we're
soon.
ready.
Pretty.
Gentlemen,
Okay, now
well,
you're.
I'm on. Doggone welcome here, everybody, to the SBAU Astro Hour. I am your proud host, Ronnie F. Herron. It's a little Monday morning vlog we've been doing for 4.5 years. It talks about cutting edge cosmology, and it's all done for SBAU, at Santa Barbara Astronomical Unit. Santa Barbara, California's longtime Astro Club. That's astrophysics and telescopes. Just happens to be based up at and supported by your Santa Barbara Museum of Natural History. Got to tell you, folks, my friends on the Zoom screen and I cover it all. There's a lot of new theories out there. At least they cover it. I go along for the ride. New discoveries, astronomy's blossoming. It's the fun science. This week, we're going to talk about Cassiopeia's big letter W asterism. It's right side up in the north sky, just above, just below Cepheus. There's a new moon coming Wednesday morning, 3:30 a.m. Going to focus on M15, a globular cluster in Pegasus. Mercury, the little planet Mercury, is near our moon's crescent with plenty of Earth shine on the moon. Up in the north, the Little Dipper's handle points down while the Big Dipper's handle points up. Polaris ain't going nowhere. We'll talk about canyons on comets and the origin of our sun. Here's a couple of quick New York Times headlines from Friday's paper. SpaceX, big starship exploded during a test in Texas, latest in a series of setbacks for Elon. He's having bad days. And get this story out of Pakistan. They're attempting to outlaw black magic, and the healers and astrologers there are worried they're going to be targeted. Also today, in one headline in this is in today's New York Times, plus an email from our webmaster. Powerful new telescope. I guess it's down in Chile. The astronomer Vera Rubin is named. It's named after her, and it's got amazing pictures. If we don't have the photos today, some of those we'll have them next week. Let's meet the gang. The commander in chief of our Starship SBAU Astro Hour. It's none other than Jerry Wilson, married to the very
Good
lovely.
morning, everybody, and good
I-
morning, Joyce.
He is the man in charge. Pat Forgy is his wife. And here is Chuck McPartland, who is our outreach coordinator. He and the president have two things in common. Both their wives have the same first name and they drive the same kind of car. Bruce Murdoch joined us. He's married to Bonnie and he's running the Santa Barbara Theater Organ Society. Anything going on we should know about and we should talk about and attend? Bruce, real quick.
Typically, we have an open console on the second Saturday of the month, as long as the theater is amenable, because if they don't have anything going then. And it's open to the public. It's free. You come in, you
Okay.
take pictures, you can play the organ. We'll show you through the chambers where all the sound is made.
All
And
right.
we generally get anywhere between a dozen and 30 people, something like that.
And this is at the Arlington Theater here in
At the
Santa Barbara.
Arlington Theater, and you enter by the side door on the Solar Street side of the theater. The main
And the
doors at the front of the theater will be locked.
only holds 12 in the Arlington?
No, it holds what,
Well,
1,700 and some.
it'll certainly give us three things to do that day. On July 12th, we'll be followed by your trip to your session with our, I guess, our planning meeting, and then a night under the stars at the museum. Here is, incidentally, Bruce is married to Bonnie, and I hope she's doing well. Tim Crawford is married to Karen, and he's on screen.
Yeah,
You're kind of the guy that monitors people's questions and things on the screen for us, right? If
I
anybody
do, but
is
it's
in.
kind of hard because there's a delay from the YouTube side to our Zoom. So I do my best.
Well, I wonder if YouTube throws ads in our 1 hour. Have you ever seen? I've never watched it long
I've
enough to
watched
see.
it. They do not.
They don't put ads in there.
Not that I know, not that I've seen.
Well, okay, here he is, Tom Whittemore. How are you,
Morning.
Tom?
Morning. Fine, thank you.
We smell that delicious sourdough bread when you get on the screen. Married to Maureen, spent years at Westmont in an incredible science lab. And every week we start this sucker off with sillies, cartoons, silly science stuff, thought provokers from
And
President
also, if
Jerry.
you want one of these coveted SBAU coffee mugs, they're available on our website.
Really? $10?
I don't know what it is. You'll have to speak to our merch
I
manager.
think they are $10, to be honest.
Yeah.
I give them after the speech to our science speakers, but I'm going to probably dump a bunch of stuff on your son, your godson, on July 10th on a
Okay.
Thursday night. And we got plenty of those left in the cupboards, don't we, Chuck? I believe so. All right,
Yeah,
this
sitting on our sofa here.
Yeah.
trying to get rid of the jerseys. All right, if it's possible to increase that, otherwise there's a pun in here. A couple of astronauts are nearing the edge of the universe, and one says to the other from the cockpit, "Hey, we did it! We hit the edge of the universe." The guy goes, "Yeah." "Well, aren't you excited?" "Well, yeah. It's just that there's nothing to look forward to." And the guy says, "You dedicated your entire life to that pun?" "Yeah, but that's all behind me now."
There's two puns in there.
Yeah.
Open the pod bay door, Hal. And here is, yeah, that's Snow White. In fact, she's looking through the telescope lens, and the astronomer behind her, he doesn't care. He says, I know, Snow White. Another dwarf star. Gets excited with dwarfs.
She's got a thing for dwarves.
Is that got last week's date on it just because you put it on there, or is that
Oh,
from
that's because it was posted on there and I don't edit within the
that came?
borders. What I clip, I don't edit.
Okay, so you got that from last week.
Yeah.
All right, here's another
Same day I
thought.
sent it to you is when I usually find them.
Why don't you read this one, Mr. President, and tell us what it's all about here?
Just a polite reminder that if you do not put your wind instruments away after use, they will attract flute flies. Flute flies.
It got you.
Yeah, it got me.
So
You
that's
know what they,
sometimes, huh?
I used to
they
play the clarinet.
well, those would be called clarinets. Never mind.
Clarinets. Oh, good one. Okay,
Getting
you can be
deep in
quiet
here.
for the rest of the show. That was a good one.
All right. That'll teach you to put a pun up. Let's go to the next one. Every good one sent out. Little girl somehow sees this on eBay. Moon rock for sale, $129.99. Authentic lunar meteorite. Buy now. And she does. Takes delivery at the door. Somehow gets on board of Elon Musk transit. It goes to the moon. Here you go. Returns it. And that's
To the
kind of
wild.
sweet. That's kind of cute. I liked it. Don't know what cartoon that is. Here is the obese extraterrestrial, the alien returning to his home planet. And the doc weighs him and says, "Oh my God, how long did you stay down on Earth?" You know what this reminds me of? The ending of War of the Worlds, H.G. Wells. Those aliens didn't do well
Oh,
here
no, they didn't either. Now,
for
this one
something
we've
else.
seen before, but I think it's a good one, so I put it in.
Well, the
All right, well, these are,
bacteria got the aliens in War of the Worlds.
yeah, right.
Yeah.
He thought about that, and I was thinking, great, man. Okay, we have two versions of meteors or craters from a hard meteorite impact in Arizona and the upside down version down in Australia, Ayers Rock.
You know, this reminds me of a really great comment that Jerry made one time, is that
What?
impact crater, that he said they really planned it well to put that visitor center there.
Tim,
And just
you have no sense of timing.
That's true. It hit right next to it. Yep. Okay. That's good. Ayers Rock is now renamed something
Uluru.
Yeah.
Yeah, right.
Uluru.
It's got
What?
3 U's in it. Every other letter is a U.
That's true. And I forget the name of those ethnic, what do they call down in Australia? The
Aborigines.
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 Okay, our satellite is worried about its origin and it asks Mother Earth about where it came from, and Earth goes, "You know, you're old enough to know, kid. You were gravitationally captured, not accreted."
And
Not
actually,
accreted.
neither one of them is right.
Yeah.
Somehow they made balls after a collision. That's amazing. Okay, we're on our way into the world of cosmology, folks. Number 226, I do believe, is this program for the 23rd of June through the 29th. And don't forget, July 10th, it's the second Thursday of the month. We're going to be gathering in the big auditorium at the museum, Fleischmann, for Martin Kakan, the Ingenuity pilot for the Perseverance mission. Okay, Commander, where are you taking us into the night sky?
Well, this
Warp
is
speed.
what's that?
Warp speed, engage.
Warp speed
was-
up there.
Stars go by us.
This is this Thursday at 11:30 in the evening, and we see in the east, this is looking east. Polaris is up here, and the comment here is that the W of Cassiopeia is a W. It's up. It comes up and it rotates around the pole star. And here it's from our viewpoint here at 34 degrees north latitude. It's pretty much up all year, at least parts of it. So, and it's loaded with really neat objects. And so Astronomy Magazine pointed that out, and I elaborated a little bit on that in the talking points. This is a beautiful open cluster.
Oh, 103. Looks like 103.
Yeah.
Yeah.
Christmas tree.
Yeah, Christmas tree.
Now, where do you get a Christmas tree from that?
It's almost upright.
Yeah.
So
It's
is this
coming
the
off there
base
about
of it
right
and that's the
now.
tree? Or-
Yeah.
Well, it's much
Pretty
bigger than
much.
that, isn't it?
Yeah. The bright star on top, Terry, is the angel. Right
Yeah,
there.
but is this the base of it or is this the base of it?
The
Oh,
farther
that's-
down part, I think.
Yeah.
Okay.
There's kind of like an arc of stars down there, Jerry. Do you see it? If you go left to right.
No, you're going too far to the left.
Yeah, that's too far. Get that bright guy down there. Right there. Now make an
To the
arc
right.
to the right.
There's two next to it.
You
all
went the
way
wrong
there.
way.
Yeah, that's
Oh, I
that's
see.
kind of
So
the base.
this is the bottom branch and this
Yeah.
is the bottom branch.
No.
Yeah.
It is not.
Well,
Okay,
we
well,
have
where's
The eye of the beholder.
where's the
Right.
bottom branch?
Don't we have a Christmas tree nebula or something?
There are a couple.
There's a couple.
there's a couple.
Mhm.
Oh,
Okay.
okay. That I was wondering.
Yeah, this isn't
Because
the
the
one
pictures
that
I've
I'm
taken of the
seeing.
Christmas tree cluster, it's a much taller tree.
Yeah.
And there
But
are
it's
three
got some-
stars, one of which is the top you can see, and then the two you're pointing out.
But this one has some beautiful contrasting colors.
Right.
Lighter
Yeah, look at that
stars.
red giant, Jerry.
Yes, right in the middle.
Really pretty.
Excellent. So
Those individual stars have names or they're just part of the cluster?
they're just part of the cluster.
Part of the cluster.
They will have catalog names, but
Right.
Oh, okay.
Double cluster?
is-
No, it's not.
This is a wide field view of M52, which is this open cluster down here.
It's another beauty.
And this one up here is the Bubble Nebula.
Mhm.
And this is about the kind of photograph I would get with a 5-inch refractor of this
Mhm.
field. And the Bubble Nebula through Hubble looks like this.
Wow.
Well, that looks
But
like
it's
a bubble.
Wow.
Wow.
Now, there's nothing in the exact center,
Mhm.
so I don't know what it's due to, whether it was a
Mhm.
planetary nebula or it's just a bubble of gas.
What would a
I
sea
think I've
star?
seen it described as a
Excuse me.
bubble from Wolf Rayet.
Oh, really?
But where is the Wolf Rayet star? There's nothing in the middle. Is it?
I think it's down there, the purplish one just below center, but I don't know for sure.
Okay. Well, there's this one, and this one. There's kind of purplish,
Yeah.
but I would expect it to be sort of symmetrically on center. And then there's this structure that looks like it could be behind the bubble. But
Yeah.
it looks like it's a concentration on the bubble to me.
Yeah. Depending on the density variations in the medium that it's expanding into, it might not be really very spherical.
Yeah,
Mhm.
that's, yeah. You,
Well, you
you
can also see the hole through which they blew it up. They're just a little bit away from 4 o'clock.
down here.
Reminds me-
Well,
Right.
in toward the purple star. Keep going right there. That's what it looks
Wow.
like to me. That's the neck of the balloon.
Would
That's
it-
just my perception.
Well, this is
That's
the
not-
bubble nebula, not the balloon nebula.
Jerry, what you guys? What would a sea star get if they image this? Anything?
Oh, it
C-star
would be
probably doesn't
very
have enough
similar to what we just
magnification.
looked at.
I missed both of those statements. What'd you say, Chuck?
C-star probably doesn't have enough magnification.
Okay. That's
But
what
it
you
would
get
be
there probably.
it would be closer to this. You'd get
Yeah.
some red smudge up here.
Okay.
Pardon me, but is C star the same as Cepheid variable?
No.
No, that's the
Stars
name
a
of
telescope.
It's a little
Oh.
telescope.
Yeah, they're wild, Ronnie. They're just a little dinky scope, and man, they are
Yeah.
really
Yeah.
popular.
Yeah, Chuck Watson brought his to the outreach yesterday at the museum.
Really?
Now switching over to the just before this is the dawn sky. You can see the sun just starting to rise here.
Mm-hmm.
And in the morning, this is the 24th. This is tomorrow morning.
Right.
And
I saw the moon come up this morning, Jerry, about 4:30.
yeah.
Yeah, and then Venus came up just ahead of 4. We have a pretty good northeastern horizon. I
Mhm.
can see these.
So Venus is up here,
Mm-hmm.
and the moon would have been higher up.
Yes.
And so this is about the last day that you can see the moon in the morning sky.
Yeah.
It's gonna be a new moon on Tuesday or Wednesday.
It's Wednesdays, I think.
Okay, and then it'll be in the evening sky as a narrow
Mhm.
crescent, which we'll see in a little
I have
bit.
it in my calendar as the 25th, Wednesday.
Okay.
Okay.
That's a Custer anniversary.
Custer?
Yeah, remember his last words?
No.
Where'd all these Indians come from?
Hmm.
So did you say did I miss Mercury on this?
Um,
Mercury's in the evening sky.
Yeah, I didn't see Mercury this morning.
You have it
No,
in the talking notes. Maybe
Is she? Go
Ron,
ahead.
that's Ronnie, that's talking about when the moon comes after new, when it's a thin crescent in the evening sky.
Right,
This is the morning sky.
right.
they will be close then. Okay, at that time later.
Yeah.
Mm-hmm.
Okay,
Couple of
but
days
not
later.
now. Got it. Just clarifying.
Cheetah's up here to the right. Is this the one where 253 is? Below
NGC 253, that's
Below
in
Cetus, right?
That's in Cetus, the sea monster, yeah. I think.
I think so too. I think it's further to the right and down.
Yeah, it's south.
Okay.
Huh.
That's a really neat galaxy.
And they just had a web picture of it.
Oh, really?
we looked last
Tom's
week. We
image up
looked
at
at
Lake San Antonio was probably better.
With an 18-inch.
Yeah.
Yeah.
last
One of the
week
best
we
views
looked
I've
at a
ever
picture
seen.
that was a very wide field of view, I think, and it was with the Rosette Nebula and a lot of nebulosity around. If you remember that picture,
Mhm.
Kind of.
it turns out that was one of the first pictures taken by the Vera Rubin camera.
Oh.
Oh.
But I didn't know the credits for that. And it's been plastered all over the internet this morning when I looked. So we're going to see more of that next week because it's got some really dramatic pictures.
Mhm.
They're taking very, very deep photographs, 100-hour long exposures
Yeah.
with a wide field thing instead of a deep look. Well, it's a deep look after 100 hours. But also, if we look off to the south, we can see M15, which is a very nice globular cluster.
That should be in the east, maybe southeast.
Yeah, southeast, I think. So I don't think it's in this map.
No.
No,
Look
this
for
is morning
Pegasus,
sky.
huh?
That would be evening sky.
Oh, yeah, that's right. And this is dawn. So this one is a very nice picture taken by Adam Block at Mount Lemmon Observatory in Arizona. Very well processed, beautiful picture. This is the first globular cluster where a planetary nebula was discovered in the cluster. And I can't pick it out.
It's also thought to have a black hole at the core.
Yeah. But you can't
Whoa.
see the black hole, but you can see the planetary nebula. Except in this picture, I can't see it. I think it's closer to the core.
Yeah, it's probably overexposed in there.
But in this picture, the planetary nebula is right there.
Hmm.
This was a much higher magnification taken by the Hubble Space Telescope.
Wow.
And the planetary nebula, anyone know the name of it?
Peas, something or other.
Yeah, Pease 1. I guess it inspired Pease to start a catalog.
Hmm.
Well, are all nebulas star nurseries?
No, nebula just means cloud, Ron.
Yeah.
Okay,
Latin
but
for
some
cloud.
of them give birth, don't they? They have enough dirt and
Yes.
crud in. So this one might have given birth to some of these or all of these. That wouldn't
No,
have
this
done
is a
all of them.
planetary nebula, Ron. That's the end of life of a low mass star, like our sun.
But they don't regenerate and become a secondary or third generation star like our sun.
To have a stellar nursery, you need dense gas, not just gas. You need dense gas, and you need something to disturb the gas and start a turbulent motion in it so that things can be knocked against each other and start accreting. When you get a single star that sheds its outer layers, it doesn't meet any of those requirements.
So this nebula you're talking about just wandered into this globular
No, it
cluster.
wasn't.
Ron, it's one of the stars in the globular cluster reached the end of its hydrogen burning life and puffed off its outer layers.
Yeah, and that's the
Ah.
nebula you see. It's just the star flumping off its outer layers.
Okay, now I know that.
Okay.
I'm surprised that they think there's a black hole in it for these old objects. That's interesting.
Well, black holes are pretty old too. There's a lot
Yeah.
of primordial ones, and black holes keep getting reintroduced as a possibility for dark matter.
Well, Mr. President, you once posted the word planet. And
Planet,
we
yeah.
never, and I must have missed it because I don't remember getting an explanation, although I know what it is. Do they know where there are some planets and we know
Where-
what they're orbiting?
What's the definition of a planet?
I would assume it circles a black hole,
That's
like a
it.
bat out of hell, but
Yeah,
they
Huh.
just they just theorize about them, right?
I think they found one.
At Sag
I don't remember where it was. So
what life would be like on one of those extraterrestrial planets.
I tend to
Exoplanet.
remember processes and connections and relationships more than isolated facts. But anyway, enough of that. This is
Yep.
the core of M15
Wow.
using lucky frame imaging done by the let's see, from the Nordic Optical Telescope. And they're trying to spot the black hole. This is a highly magnified view of the core of this thing. So they're way in there. Doesn't say how big the telescope is, though. But
Well, obviously the stars that are in there close to that black hole have got to be moving faster than the other stars outside.
that's how you would spot it. That's how Andrea, what's her name?
Yes.
Yes, at UCLA did it. She took a movie over 12 years by taking still frames.
Mhm.
And this is probably one of the still frames of a future movie of M15 core. They're trying to get to see the similar moving of things real fast around nothing, around the black
Wow.
spot.
12 years.
But
Yeah.
Well, she was a
You
young
suppo-
woman. She had lots of time, lots of patience.
Boy,
Things don't happen real quick in astronomy, as you know.
analemma would be a lot easier.
That happens each year. It's been done. You
12
got
years.
to do something
Yeah.
new to get a PhD.
Tim Analemma was a very famous mathematician.
Yeah.
well,
And her
over
sister, Anna Axiom.
can they actually see those stars that are around a black hole moving?
Yes,
Yes,
Yeah.
that's what we were
that's how
just
you
talking
spot
about.
them.
So in
Yeah,
other
that's
words,
how we-
take a series of pictures and it'd be in a different spot, whereas right now everything stays where it is, even though they're moving. Orion's belt hasn't changed.
Take this picture every year, and you will, over 15 years, you will see stars moving.
Yeah.
Well, they did that for the black hole in the middle of our galaxy.
Right.
Yes,
And
that's right.
yeah.
Wow.
Boy,
Okay.
that's
Now
crazy.
this is the evening. This is the corresponding shot to the dawn. This is the dusk picture. You can see the sun is just setting here. This is about 8 o'clock. The sky is not this black at 8, but there's Mercury and there's the moon. This is the 26th. So the other one was the 24th. So in 2 days, it went from one side of the sun down here to this. Actually, this is about a 1.5 day old moon. And it is, this is how much at 26, which is
Thursday.
Thursday, yeah.
Thursday evening at 6 p.m. This is the percent, I think it's about 2% lit. This is what the moon will look like. But you will be able to, this is not a picture, this is a map. You will be able to see all of this stuff in some details, especially with a telescope.
With Earthshine.
Through Earthshine. This is a picture of Earthshine on a 2-day-old moon.
Huh.
So it's pretty easy to
Overexposed.
see. It's a hard picture to get.
I've never heard that term in any song.
What?
Earthshine.
Yeah.
This is the
Moonlight.
smile without a cat.
Yeah, I got you. So at this rate, by our next star party, which will be 2 days after Martin's speech on the 12th of July, we'll have probably a full moon, won't we? Pretty close.
2 weeks from now, about,
Not sure. Yeah,
I think we'll be a little past full.
okay. Love it.
And since we were looking at Mercury in the sky, it turns out that on June 26th, Mercury is, they don't call it a quarter Mercury. They call it a bifurcated, is that it?
Really?
Yeah, I mean half and half.
We would call this a quarter moon, which when it
Yeah,
doubles
but
the-
they don't use that on Mercury.
I got you.
Quadrature or something like that?
It's something like that.
Yeah, I just heard that recently. I don't
Yeah, I
recall.
put it in the talking points several times, and you can
Yeah.
see how long my memory is. So
It's obviously
What?
off to the side of the sun,
mhm.
not in between or on the other side.
So no big oceans here, maybe. Well, there's a lot of smooth plains. This is like more like a core of a planet than and the moon, of course, is made out of the surface and mantle of a planet, our planet. And the planet that hit us a long time ago, Theia, is in 2 large deposits around the equator of our planet, buried around the mantle depth. It didn't disturb the core, but it hit the mantle and skidded a lot of it off into space to become the moon. Here, if this got hit, it didn't form a moon around it, it just sloughed the surface and the mantle off. This is more of the core, high density.
Aren't
Also
those
much higher temperature, so the rock's a little more fluid.
Yeah,
fluid? As
plastic.
in lava?
Yeah,
Plastic is better, yeah.
yeah. You get
Those big-
at 2/3 of the melting point of materials, you can get plasticity in them. And what happens is that when you deposit in a vacuum, you deposit layers, because we made multi-layer filters by depositing up to 125 layers of different dielectrics on the material to get really sharp cut on and cut off filters. And it's tricky to do because when the material you deposit in a vacuum chamber hits the surface, it freezes because the surface is cold and the material coming in is hot. And so the material coming in, you want it to be a crystal, single crystal, or as close to it as you can get. So you want the substrate heated to about 2/3 of the temperature of the melting point of the deposited material so that it can move around on the surface. It doesn't like come in and hit something cold and freeze in place. It can learn its neighborhood, shake hands with everybody, get comfy with its neighbors, and so form crystal structures on the surface, which are strain free. And that's the way that you make these multi-layer filters, is adjusting the material temperatures for when the stuff comes in. When spectral coatings were first, anti-reflection coatings became complicated back in the 60s, you'd get optics that were multi-coated, and they were just crappy because people didn't understand how to make that stuff right. And so multi-layer filters became a new opportunity to not control all the right variables. Took them a while to get that down. Now everything you get is pretty well understood and worked out. So, but it's a very interesting part of technology.
Well, my
Well,
glasses and yours too probably have the anti-reflection coating on them, but the base material of the glasses is polyethylene, or I'm sorry, polypropylene. No, one of those. It's a plastic.
Oh, if it's plastic lenses, I don't
Yeah.
know plastic lenses. That's a whole different ballpark. I know plastic lenses was very, very difficult to get control of and did not make high quality optics at first because the plastic molecules are long polymers. And when you grind them and polish them, you rip the polymer out of the surface. And it's not just the part that sticks up that you rip off, it digs out. It's like a snake underground. You pull the whole thing out and it disrupts the surface. It's not like glass where you slide a small molecule over the surface by heating it up with the friction. So getting it so that you could make a good smooth plastic lens was, until very recently, I don't think that they made high quality lenses with plastics.
are we going to be quizzed on this, Professor Wilson, later? Because I'm not sure I got it.
Yes.
If you want, there will be a test.
Okay.
We've got a guy on the YouTube side, Astro Deli, and he said hello from India.
Hello.
Hello. Wow.
Does he have
Yeah.
a question or comment?
He might later. Let's see what happens.
Okay,
Got to be the middle of the night there, doesn't it?
could be. So anyway,
Wow.
this is 9 o'clock at night on the 26th. Mercury and the moon are at the same apparent latitude. That's why I picked the time, or the same, not latitude, the same height above the horizon, above the ideal horizon. So,
Huh.
I'm looking around, I don't see anything else. Okay. Oh, yes, that's right. The Beehive cluster is up here, and M67 is here. I think I have a picture of M60. Oh, no, right. Excuse me. Gesundheit.
I'm allergic to this program.
Okay, well, Polaris is up there, of course, that's all year for us. And this is the easy star hop for how to find it. The pointer stars on the Big Bear point right to Polaris. Polaris is a triple star system, A, B, and C, and Polaris A, Polaris B, and then Polaris AB. That is, this is a double star. There's the double. It's a close double. This you can split with our amateur telescopes, but this requires some work. You see how they've positioned it so the diffraction spikes are on either side of the object they're looking for. That's a trick.
Jerry, Sean showed me something the other night out at Westmont that I didn't know. He said if you take the bowl stars, it's 5 of those up to Polaris. The distance between those bowl
so
stars.
if you take this as one unit.
Yep. And he says you go 5 of them.
3, 4, 5. Yeah, but I just go till I hit the star.
Yeah, me too.
Yeah, the next bright star. Yeah.
Right.
Program on astronomy.
It's not quite in line, but it's close.
I'd have to.
Go ahead. Bruce, you were saying something?
He's on the phone with somebody.
Oh,
Polaris is a star that they'll never see. They don't know exists in Australia, right?
they
have their
know.
Northern
Is there
Australia, you might be able to get it.
Yeah.
really?
Polaris is not exactly at the pole, as I'm sure everybody knows. It's about little under 1 degree off, I think, or about 1 degree. So it actually orbits a point around like this. And it's a Cepheid variable. It's a long-term Cepheid variable.
Yeah, Ronnie, I'm sorry. I was thinking of the Big Dipper is visible, but Polaris probably not, because I don't think it's maybe only a tiny bit of Australia, if any, that's above the equator.
But we don't have a a star over the South Pole.
There's one fairly close. It's not very
Okay.
bright, though. It's not naked eye.
What's set to replace this one in a few thousand years? Polaris.
Big is the next big bright one.
Well, I think it's going to end up on Vega after a
Vega.
while, and then at 25,000 years, it's going to be back on Polaris.
And that's because our spinning Earth wobbles, or
Yeah, it's like a top that slowly, if you have a top and it's spinning, it'll slowly precess. Even though it's spinning much faster than that, it'll slowly precess. And that's a similar motion. When you read these people that claim that the pyramids line up with north-south, and they use Polaris as the north, Polaris wasn't the North Star when the pyramids were built. That was about somewhere between 5,000 and 9,000 years ago, depending on which pyramid you're talking about. Polaris was not the North Star.
Yeah. Thuban.
Thuban was that.
Thuban.
I got these messages from the guy in India. He says, I'm also doing live stream 30 minutes before. I'm 17-year-old, sir. I captured Nova, which recently happened in Lucas constellation. And then he asked what telescopes we have. I love everyone in this age. You are to inspire many others in astronomy in my country in this age group. People quiet their job and rest only at home, even in my home also. I don't quite understand that, but
Did he give his name?
he goes by Astro.
Okay, why don't you
Hey.
get on SBAU.org, Astro Deli, and contact us. We'd love to hear from you. Send us a letter or an email.
There you go.
Okay.
All right. Love to hear from him. All right. Another cluster? No.
This is Messier 67, which was out there in Cancer. There is the Beehive cluster M44, and then this out on one of the arms, taken by, it's an amateur photographer, Jim Mazer. This is the oldest known open cluster in the Milky Way. One is not the oldest known Milky Way. There's several are older, but this one is a paradigm study object, apparently in stellar evolution, for a number of reasons. And they list those. I listed them in the talking points. So
It's used, I know, if you're trying to figure out the limiting magnitude of your camera, you take an image of M67 because it's got stars of hugely varied levels of brightness, and they're still fairly well separated. So you can pick them out and figure out how deep you can go with your camera.
That bright blob in the upper left, near the center, but left upper, is that a part of it, or is that
that
is that a distant
this is what you're
galaxy?
talking about, Ron?
Yeah, is that a part of the cluster, or is it a distant galaxy, or is it a
That's a
red
star.
giant? What?
That's a star, probably part of the cluster because it's already evolved into a red giant.
Yeah.
Okay. And red giants are rare, but red dwarfs are common. In fact,
Yes, but there won't be any red dwarfs in here because you can't see red dwarfs farther away. If you recall last week or the week before, that's why they're studying this little teeny galaxy as a satellite galaxy to our galaxy, the Milky Way, because we can see red dwarfs in that galaxy. So it's not too far. It gives us a look at the red dwarf population.
We can see red dwarfs in another galaxy, but not in our own?
Not in most of the parts of our own.
Gee, I wonder why that doesn't make
But
much
we'll
sense.
have to go back and revisit this again.
Okay.
Key point of this one is that the cluster contains no main sequence stars, bluer, that is hotter, than spectral type F. And if you look at a Hertzsprung-Russell diagram, this is M67, and this is NGC 188, which we're not talking about the blue ones here, the green ones, teal ones. But M67 is like this, and then it departs the main sequence. So it would be, if it had more hotter stars, it would continue up here. So this is characteristic of this cluster, where they have stars which have terminated hydrogen fusion in the core and are destined to become red giants.
And that's where they turn off and sort of go horizontal like that on there. So if you find where that is on a Hertzsprung-Russell diagram, it kind of tells you the age of the cluster.
Right.
And so we're talking about the blue stragglers now, right?
No.
Oh, okay. Sorry.
Blue stragglers would be upper and left here. The yellow dots you see up and left.
Okay. I'm getting another message here from this guy, the fellow in India.
Why are there arrows next to absolute magnitude on the left and temperature at the bottom? Why does it point to the point to the?
This is low temperature. This is high temperature.
Oh, okay.
No, excuse me. I got it the other way. High temperature, low temperature, dim. No, absolute magnitude. This is bright and this is dim.
Actually, it's the other way. Bright is upper left.
That's what I would expect. But why is the absolute magnitude going down?
Well, brighter is a smaller magnitude.
Oh, that's right. Of course. Okay, I'm going to have some more coffee here.
Take it intravenously out of the tongue. You'll do fine.
Astro Delhi says my observatory is completed in the next 2 years in Latka.
Wow.
One of the best stargazing places with Bordeaux One skies. And he invites all of us to come.
Anyway, this cluster has a number of 4 billion-year-old stars in it. It's and the spin of those stars, the period of them is not the period. The rotational period is 26 days average for all those old stars. And our sun is 25.38 days. So it's very similar to our sun. And they speculate in here that the key properties of the sun, size, age, rotation period, indicate that this may be a source of our sun. But I haven't read this anywhere else, and I know there's active hunt for our sun's sister things, sister stars, and I don't think M67 was included in the other articles I read.
Yeah, I think they're just saying like the sun.
Yeah.
Well, is this a representative of pretty much all the stars that are in that cluster? Is this the number that they've got on the screen?
If you count all the dots, I don't think so. Let's see, I have down here the number of estimated stars in there.
It's the ones you can get a good reading on anyway.
Yeah.
That's several hundred dots we're looking at, so that's a good cluster. And
there are, well, no, that's the age. The total star count has been estimated well over 500.
Okay, that's about.
It's a loose star cluster.
So every cluster could have a similar diagram like this, only it would look different.
All stars in the Milky Way have a fit on a diagram like this.
All stars that exist.
Right.
Huh. Wow.
Okay, moving on to Canyonland on a comet.
Canyons on comets. Ooh.
This is
a rubber
comet.
ducky.
This is a comet taken by the Rosetta spacecraft on comet.
Churyumov Gerasimenko.
Thank you. I just try struggling with that. This is very dramatic. This is a cliff. When I first saw this, I thought this was somewhere in the Sierras or the Rockies. It's a kind of cliff that looks very nice to climb. And it would be very safe if you fell off up here, you could have a few cigarettes before you landed down here. You fall very slowly.
Bounce your way down.
Yeah. And
Yeah.
this is apparently snow and ice down here. These are volatiles that when the sun hits it, they start steaming off, and you can see a faint glow here. But when you have a real small body, the gravity is very low, and you get dramatic surface features. If this rock were on Earth with 1 g of Earth gravity, this structure would not be stable. It would collapse into a much taller structure and probably into a rubble pile. So you get these dramatic surface features on small bodies, but you can see all this volatile material up here, snow down here. And these boulders are on the order of 10 to 20 meters in diameter, according to the caption.
Well, maybe there are two globes that came together, and that's the in-between point.
Yeah, this is the rubber ducky, and that's like the neck region.
Yeah.
Okay, got it. Is this where we lost for a while that went into the shade, one of our landers?
It was a European Space Agency lander, Philae.
Oh, okay. And it finally got its solar panel recharged. The sun finally hit it or something.
Periodically.
They finally got at an angle where they could get a transmission from it, but the batteries eventually died.
Yeah.
Okay, but it's
How
not been.
tall are these cliffs?
What'd you say, Bruce?
How tall are the cliffs? Like 400 or 500 meters?
I didn't, if these are like 20 meters,
Yeah, that's what I was guessing.
then I guess this is about 5 of those. That's about 100, 200, 300, 400. Yeah, about 500 meters, 400. Okay. This is an artist's rendition of a very large meteor that has been spotted heading in toward the inner solar system, not toward Earth. We're not in danger. This is 85 miles in diameter, roughly. It's C 2014 UN 271. It's the second most distant body originating from the Oort cloud that is found to be chemically active. That means it'll have a tail. Chemically active doesn't mean it's on fire necessarily. It means that the sun is boiling off volatile materials.
You accidentally used the word meteor. Meteor is a bad thing. It means it's hit our atmosphere.
Yeah, sorry, comet. It's got a tail, it's comet.
Wow. Artist rendering, huh?
It's still way out there. It's going to be hopefully spectacular when it gets close.
Yeah.
But this
It's
is not
located halfway between the sun and Neptune, or about 16.6 AU.
As long as it's not too spectacular.
Yeah.
Yeah. Well, that one, what, 2032, one's going to hit the moon. And while everybody's breathing a sigh of relief, you know, it could splatter a lot of boulders off and come hit the Earth anyway.
Ooh.
Or at least the satellites out there.
Yeah.
Well, I don't know about you, but I'm glad there's a lot of space out there.
Yep. There's a lot out there. That's why it's called space.
Thank God, yeah.
So anyway, the active material coming off this by spectral analysis is carbon monoxide.
Really?
And this was done at the spectral, the observations of it, not this detail, this is again an artist's rendition, is done by ALMA, the Atacama Large Millimeter Array of 66 radio telescopes. This is an artist's impression of it made during the time it was being built, and showing it when it was completed. Looks very dry up there. So there are 66 radio antennas, and they operate in an array as an interferometer, giving very high resolution. The effective largest aperture is from the farthest, the distance between the farthest two antennas. That would be the effective aperture. And you can figure out its resolution in that dimension from that.
Not a lot of rainstorms in that area.
Yeah.
Yeah, maybe an inch a year.
Where do they get their
maybe an inch a century?
How do they
Okay,
get their
well,
power? Do they manufacture their own power?
They make what?
How do they get their power? There's no grid connected to a city anywhere nearby, is there? Is it all solar panels?
I assume so.
And Vera Rubin's not far from this?
She's in Chile, but I don't know where its relationship to this. I think she's in Tololo.
Wonder how many they have down there. Every one of the mountains in that desert has got a observatory on top now, doesn't it?
Or two or three, yeah.
Chile is becoming a hot center of astroscience.
Wow.
do they have to worry about the gaseous emissions from diesel generators, condensing on the optics?
I
Well,
don't.
these are radio telescopes here.
Oh, that's right. Okay. Yeah.
I don't think that these guys. If I were building them, they'd all be solar
Sure.
and
Yeah,
battery.
but the sun doesn't shine at night, so then you gotta have to have a big battery to store it up during the day.
Yep.
Yeah.
But you'd have to see fields of those solar panels. I don't really see them.
I
No.
don't either.
Maybe there's
Huh.
one on the back of every dish. I don't know. Good question.
Wonder what the nearest town is. It's
The nearest
Santiago?
Kmart is probably pretty far away.
Yeah.
And those mountains in the distance, that's the Andes, isn't it?
This is in the Andes. Yeah, they're building. Yeah, this is the Andes.
Wow.
Okay, now we've had this before, changing topics a little bit, but we were talking about comments from the Oort cloud. This is the Oort cloud sketch schematically. It shows it's on a log scale. So this is 1 AU, this is 10 AUs, this is 100 AUs, this is 1,000 AUs, 10,000. So between 1,000 AUs and 100,000 AUs out here is the Oort cloud. It actually is about halfway between Alpha Centaurus and the Earth. But because of the log scale, it looks like it's really close to Alpha Centauri. But you want to get all these different features on at the same time. This is the heliosphere here, which is where that inner layer, which is where the Voyager 1 has now passed the heliopause and the termination shock wave. We've left the heliosphere and are now technically in interstellar space, but it's in the Kuiper belt and it has not reached the Oort cloud yet.
Are the three things pretty much the same? Kuiper, Oort, and the asteroid belt?
Yeah,
No.
they're just lumps of rock,
Okay.
but they're different regions and they are governed by different gravitational symmetries of the sun with its central spherically symmetric gravity governs the asteroid belt. And to some extent, in a looser sense, it governs the Kuiper belt. And in a much looser sense, it does the Oort cloud. But there's a feature in the Oort cloud where the sun is not the only thing determining it. It's picking up gravitational pulls and tugs from the rest of the galaxy out there that's giving it a spiral arm shape, which we're about to get to.
Also, Ron, the farther out you go, the icier the bodies are.
Yeah, temperature's lower. So
Well, ice is everywhere, but you mean there's more
That's-
water out there?
But no, don't look at it that way. Everything there is, the ancients with their 4-element periodic table,
Right.
air, earth, fire, water, they actually had it together for the state of matter, but not for the elements. Because every element is in one of those states: solid, liquid, gaseous, or plasma. And so what it is, like, out this far out, rocks are going to be solid and ice is going to be just as solid. In close to on Earth, rocks are going to be solid, but water is going to be liquid and vapor. So everything goes through the same 4 phases. It's just what
Right.
it's made out of out here.
We got most of our water on the Earth came from comets, didn't it?
That's
They think.
there's no one source. The the current thinking is that the water we have on here is a mix of almost everything.
Well, I never hear this kicked around by science, but I have a feeling every astronomer and scientist on the Earth thinks that every star has similar layers like this. And we just can't see them or prove it till we get there, get to a star, you know.
No, the way
Proxy-
stars are structured, we've pretty well got that nailed. The layers in it and how they progress and how they age. We can predict virtually everything about a star.
We just
Solar systems vary differently. We have giant planets out 10 astronomical units, but other systems have giant planets orbiting their sun in a day or two. So there's a wide variety in solar systems.
But the stuff in the Oort and in the Kuiper are probably just the residual stuff from the original stuff that went crazy back in 4 billion years ago to start the whole process. That's just the stuff that didn't coalesce into planets or sun.
Or stuff that got smashed together and ended up out there.
Yeah.
And it's pretty much galaxy wide. Well, look at that.
So
Love it.
this is the Kuiper Belt and outer solar system planetary orbits shown here. This is Pluto's orbit. This is the planets that follow the ecliptic plane with the sun, Neptune, Uranus, Saturn. I think the Earth is the red one in there. This is the Kuiper Belt object. This is, I don't know a name for this, but I think it would have a name now. So, and then the Oort cloud, this whole square here is this little square here.
Wow.
And it shows different lobes and structures of the Oort cloud. It's got a disc-like feature here. But it's basically spherical. And it also has a spiral structure now. So this is the ecliptic plane. And this is the ecliptic plane here. And this is the galactic plane, because we're tilted. Our ecliptic plane is tilted from the galactic plane.
About 60 degrees, Jerry.
Yeah, and that's about 60.
Mm-hmm.
And all those rocks and pieces of ice are orbiting the sun.
Yep.
Yes, but I think they can be bribed away pretty easily. Something passes. What is it? One of the star we were looking at, we talked about several months ago, is going to come about one light year away from the Earth's, from our sun. And I'll bet you it perturbs or just, just changes some outer orbits there.
And potentially tosses stuff into us.
Yeah.
Well, Mr. President, is this the part of your talking points that was supposed to be the origin of our sun?
No, this is stuff floating around our sun.
Oh, okay. So we probably won't get to that one until next week, maybe the origin.
The origin of the sun. No, we talked about that 2 weeks ago.
Well, that was in your talking points this week.
Yeah, I mentioned that someone was speculating that M67 may be where the star cluster our sun came from. It might be, but I think it's a low probability. They were just, as Chuck pointed out, it's just because of the similarity of the rotation period of the suns in there to our sun, the properties of the bulk of the stars in there, at least the spectral types that are similar enough to our sun. And
Well,
we came from a open cluster like that if it wasn't M67.
I wish you could explain in 2 minutes why there's a spiral.
I wish I could
Tidal
too.
forces.
That big letter S, I don't understand it at all. I'm sorry.
That's tidal forces from the center of the galaxy as we go around.
Yeah.
Oh, well, it doesn't look like a sphere.
No,
No,
it's tidally disrupted.
right.
That's superimposed part of the sphere, or the sphere just gets twisted into that shape somehow.
Yeah,
Okay.
let's see, it's a shape oriented primarily by the combination of the galactic plane and the ecliptic plane. And
It's
this,
just like our Galaxy's plane has a
Right.
potato chip shape. The same thing is happening here.
yeah,
Well,
we,
go back to it again and tell me those aren't arms on it, like the arms of the galaxy. Is
Yeah,
that
they
They
kind of
similar?
are.
they are arms like an arms of a galaxy.
Oh, okay. Got it.
And the same source of it, it's like a traffic jam, but it's not in the galaxy. We're going around a central gravitational field, a roughly centrally spherical gravitational field.
Wow.
All the stars in it as a combination, as an ensemble, and that gives us this structure. And a similar thing is warping our spherically symmetric gravity here close to our sun and giving it a similar spiral structure.
Wow. You guys, before we go, Tim, Tom, Bruce, you want to weigh in? What do you think?
See, if you're driving down the freeway, there's two things that you cause traffic jams. One is that someone stops, and then the guy behind him starts, and then the first guy starts up again, and then the second guy starts up. But there's time delay. There's time delays. And the time delay is what causes this thing to move, to be a wave that moves backwards through the traffic. And that's the similar effect that gives you spiral structures. It's a traffic jam. If you sit down and you figure out these stars, they get tugged ahead, and then it pulls, and then other stars sort of pull them back. This back and forth motion with their time delays in it gives you that stacking up effect.
And this is happening in our Oort cloud.
Yes, it is.
Anybody know how many AUs between us and Proxima or Alpha Centauri?
As a matter of fact,
There it is.
this is 100. This
Oh.
is about
Didn't see that.
200,000, about 300,000. So about 250,000 AUs.
Okay, well, that the Oort cloud doesn't extend that close. That's keeps
No,
getting
this you can't get closeness off this diagram because you're used to looking at a linear axis, and this is not a linear axis.
Right, it's
logarithmic.
logarithmic.
Wouldn't you say this like logarithms? Or am
Yes.
I off?
Yeah, it's
Powers
like,
of 10, Ron, powers of 10,
Say again?
just powers of 10, you know.
Yeah.
the
Yeah, I'm
the
Right
logarithm.
in the middle between two of them, like 1,000 and 10,000, is 3160, right? The square root of 10.
Mhm.
yeah.
So a logarithm, Ron, is the power to which you need to raise the base of the logarithm to get the number.
Yeah.
So if you're in a 10 base system, a logarithm is the power you need to raise 10 to get that number.
It's pretty much the way a slide rule is laid out, isn't it?
That's
Yes,
right.
it is.
That's right.
Exactly.
Mhm.
Yeah, because in that a
I've seen 'em. I
multiplication
understand.
is addition.
Gentlemen, we've gone over, but I'm just still fascinated, as I always am, though light years behind, or at least AUs behind you guys. Thank you in India and everywhere else, and we'll head back to the museum now until next week's show, number 227 of the SBAU Astro Hour. And we'd love for you to join us. In the meantime, we say farewell. How, Chuck?
Hasta